Hey guys, all right, so this is the last section of this unit that we're going to be doing. It kind of ties in all of the exponent rules. And so now you're going to see exponent rules tied into real world situations. So this note section is actually going to be really short because what they're talking about we don't have any actual practice problems within the notes. So these will make a lot more sense and be applied when we get to the practice problems. Okay, so what we're going to be talking about today, we have these three different formulas right here. So the first one we have, you might want to pause the video and write these down. You have a formula that's describing an exponential growth. So we've been talking about things that grow exponentially or things that grow very rapidly. It's not like a straight line at a constant rate. It's almost like every single point that you're at, it doubles and doubles and doubles and doubles and kind of creates that increase in your graph like we did last week. So now we're going to look at real world situations like population growth, or growth in investments that you make. Or we talked about one last week, like with the coronavirus. That is what is growing exponentially. And on the same kind of idea as that, there's also exponential decay. So things can also decrease at a rapid rate. Things like the stock market can crash and they just decline very quickly. Okay, so these are essentially the formulas that they have to find that rate at which something is increasing exponentially or decreasing exponentially. Okay, so these formulas are how to calculate and measure how much something is increasing. That's the exponential growth, or if it's decreasing, that's the exponential decay over a period of time based on an initial amount or starting point. Okay, so we're going to look at some real world situations here in just a second that show how to calculate that growth from a starting amount. Okay, and then the last one that kind of stands on its own a little bit, but still it's talking about something that can grow exponentially is this last idea of compound interest. So y'all probably don't deal with a lot of interest in like your everyday lives, but typically the first thing I think of is like when you have a credit card. If you do not make the payments every single month, the amount of money that you owe builds interest. So not only say do you owe $50, but if you miss that payment of $50, then they tag on a percentage of that amount at the end of it. And then the longer you go without paying it, the more that interest builds, and essentially it continues to grow exponentially. And so this is the formula that they use to calculate that amount that is tagged on to your initial start. But it's not always a negative thing. Like if you put money in your savings, it also builds interest to it. So say you put $2,000 into your savings account over a period of time, they add a small interest to the end of it. And so over the years, that interest builds and builds and builds, and eventually you have more money than what you started with. Okay, so that's what compound interest is. Okay, so this is a very, very short note section because a lot of it is going to be in its application of these formulas when we get to the practice. But before we do that, I want to kind of break down these different parts of the formulas. Okay, so first we have y equals a times 1 plus r to the t power. Okay, so what does all of that mean in this situation? Well, it's the same for the growth and the decay, so we're just going to talk about them both at the same time. Okay, so let's look at this y first in both of them. So what does that y represent? It represents your final amount. It represents that growth or that final decay amount. Okay, so when you calculate all of this stuff on the other side, it's going to tell you your exponential growth or your exponential decay amount. Okay, next we have this a value. in both of them. Okay, that's going to be the initial amount that you start with. Okay, so this gives you like an exponential growth. It tells you how a population increases. So that A amount is going to be the population that you're starting with. Okay, and then they're going to want to know how it's changing over a period of time. And so the Y would equal that population in 20 years. Okay, next we have our R value in our equations. Okay, so the R represents the rate of change. Okay, so we know the rate of change is essentially its slope. So how quickly is it increasing? And we would definitely see that in its graph for sure. Okay, so that's its R. All right, and then finally we have this T value. All right, and that represents time. Okay, so how much time is passing? How much, what is your starting year or your starting date and your ending date? Okay, so the amount of time that passes is your T value. Okay, all right, so now let's look at our compound interest, which it has some similar variables. All right, so again, we have that Y value. Okay, so that's going to be your final amount, your final compound interest. All right, this next one's going to be a little different. This one has a P value instead of an A, but it's essentially the same thing, but this formula uses a P. It's your starting amount. Okay, so we talked about like the amount of money you put in your savings or the amount of money that you owe on your credit card. Okay, that would be your P amount. Okay, that's the amount you're starting with. Okay, then we have R once again. Okay, that's the rate of the change. Okay, so how quickly it's changing over a period of time. All right, now we have a new variable in here. It's its N value. All right, so N represents the number of times the interest is compounded each year. All right, so how often is interest added to your amount? Okay, so like I said with your credit card, every single month that you don't pay your credit card bill, they're going to add more interest to that amount. Okay, so that would be the number of times the interest is compounded. Now with savings, it's a little different, and it's also usually not as big of an interest. Okay, that's how people get into extreme credit card debt so quickly, because the interest that builds on the amounts when you don't pay it back. All right, and then once again, we have our T. All right, and that's again the amount of time that passes. All right, so that is the end of the notes for this. Make sure you get those copied down on a sheet of paper. Take a picture, submit those into Google Classroom, email, remind. If you have my phone number, text it, I don't even care. Just make sure that you are staying on top of it, and then go to the next video for the notes.